This is video 3 of Unit 9. In this video, we'll talk about types of reactions. This whole chapter is about writing chemical equations for reactions. So today we'll show you the 5 types. There are 5 of these chemical reactions that we want you to be aware of and to be able to spot what the chemical reaction looks like. In fact, this will help us write chemical equations in the end. So let's get to it. The first type of chemical reaction is called synthesis. Now the word synthesis, if you have heard it before, to synthesize something means to make it. So synthesis refers to beginning with 2 separate substances and combining them together. This is what it means to synthesize. So a few examples. We have magnesium plus oxygen combining together to give magnesium oxide. In fact, you should have performed this lab already. And another example, in the first example we have 2 elements forming a compound. In the second example we have 2 compounds forming a bigger compound. So it could either be elements or compounds, but the whole point is you begin with less on the left side, or you begin with smaller parts on the left side and a bigger whole on the right side. You're synthesizing, you're bringing them together. That would be synthesis. The next one is the exact opposite of it, called decomposition. You may know that decomposing something means breaking it apart. So here we begin together and we spread apart. This means to decompose. Break down into simpler substances. Again, you could have a compound breaking down into elements, as we have here, or you can have a compound breaking down into simpler compounds, as you have here. This is decomposition, breaking down from a bigger substance into smaller substances. The next one is called single replacement. This one is also in the name. You can find out what it is. There's a replacement happening with a single element. So what you have is you have an element, C, represented by C here, which comes in and replaces another element. In this case, C comes in and replaces B. Now B then ends up by itself. Notice that's what you see on the right side. B is now by itself, and C is now with A. So a single element replaces another element, and that one becomes single. That's the idea. Now, what will happen, as you'll see, is that the element will always replace a similar element. By that we mean a metal will replace a metal, and a non-metal will replace a non-metal. Replaces a non-metal. And in this case, if you take a look, C, do you think C is a metal or a non-metal? C is a non-metal because it's replacing another element that's on the right side. Usually you write metals and non-metals. Non-metals. Like, for example, sodium chloride. So the non-metal will replace the non-metal. If C were a metal, it would replace a metal. And that's exactly what you see here. So you see magnesium, as an example, coming in and replacing hydrogen. Now hydrogen is a non-metal, but hydrogen acts like a metal. That's why it's with a group 1 element. So magnesium will actually replace hydrogen, and then hydrogen will end up alone. Notice hydrogen ends up alone here, whereas magnesium is now with chlorine. Now realize that hydrogen is diatomic. That's why we put a 2 down here. The magnesium is not diatomic, so we don't put the 2. So this would be single replacement. The next one is a little more complex along the same lines, called double replacement. So here we have 2 ions exchanging places. If you take a look, B and C will exchange places. So on the left side you have technically the B and the C will swap places, and C will swap place with B. So you see A was with B on the left side, now A is with C. C was with D, now B is with D, is the idea. So the ions are exchanging places. Now usually what happens is we'll exchange places, the first spot will exchange places with the first spot, and the last spot with the last spot. And that's what you see on the compound example here. So this is potassium iodide. The iodine will come in and replace nitrate. Nitrate will come in and replace iodine. You'll see K is with I here. Now Ag is with I. and K is with NO3. So here Ag was with NO3, now Ag is with I. So these two actually swap places, and usually this will be the case. The last two ions will exchange places. In the example up here, that's a little tougher to see, but the more you work with these, the more you'll see this is the case. So double replacement, usually the way to spot double replacement is that you have two compounds, and you have two compounds on the right side, two on the left and two on the right. And we'll be able to see these here in a minute in an example. The last one, the fifth reaction type, is called combustion. This one's the probably most familiar and the least like all the others. This one's actually the easiest to spot. What you have in combustion, combustion is another word for burning. So it's just a fancy word for something burning, like a piece of wood burning. And in combustion you have what's called a hydrocarbon. And a hydrocarbon is a compound made of carbon and hydrogen. And this really is fuel. This is what fuel looks like. In fact, in your cars, you have C8H18 as your fuel. So this hydrocarbon reacts with oxygen, that's what burning means, forming carbon dioxide and water. So here is our hydrocarbon, C3H8. Here is oxygen. Oxygen is diatomic. You have to make sure there's a 2. And then the two products are always carbon dioxide and water. So this is the easiest to spot because the reaction will always look similar, or it's always the same except for this portion. The hydrocarbon may change up. It may be C8H18, maybe C3H8. There may be an oxygen in here still. But the rest of it will always look the same. This portion and this portion will always be the same. You're always looking for CO2 and H2O as a product. Now, this is actually also the reaction that happens inside of the human body. Because anytime you eat a bunch of hydrocarbon, and as you work throughout the day, you breathe in oxygen, take in oxygen, and you break that hydrocarbon, you burn it to give you energy to work in the day, and then you breathe out CO2. Everybody knows or should know that carbon dioxide is what we breathe out, and you also breathe out water. So this is your combustion reaction. This is a teacher or a student, anyone undergoing combustion at all times. If you ate something, you're undergoing combustion now. And here are a few examples. So why don't we try a bunch of these together? What we ask is for you to categorize what type of reaction this is of the 5 types. So let's take a look at the first one, part A. Now, at the first one, looks like we have an element and a compound, and then we end up with an element and a compound. So this is a good candidate for single replacement, and it looks like that's exactly what's happening. Aluminum here is coming in and replacing iron, and iron is ending up in the spot where aluminum was. So aluminum used to be by itself, now iron is by itself. This is single replacement. Example 2, part B. We have potassium and sulfur combining together to give you K2S. Now, this looks like synthesis because we have two elements combining into a compound. We have simpler substances here and a more complex substance on the right side. This is good old synthesis. The next one, part C, we have a compound and we end up with two compounds. So in this case, the compound is breaking down or decomposing into simpler substances. This is called decomposition. Part D, we have a compound on the left, a compound on the right. After the arrow, the product's also two compounds. So anytime you have two compounds, this is a good candidate for double replacement. And in fact, that's exactly what happens. Calcium will come in and replace sodium. And you'll notice on the right side, now sodium has nitrate with it, and calcium has hydroxide with it. The two swapped places, essentially. And sodium came in and swapped places with calcium. You can also think of it as the nitrate swapping places with the hydroxide. Either way you think about it, it works. So this one should be double replacement. Double replacement. And the last one here is actually the one that's left, which is combustion. So you see we have a hydrocarbon being burnt with oxygen to give us CO2 and H2O. So this one is combustion. So hopefully this wasn't too bad. Hopefully this makes sense. Go ahead and try one on your own, and we will practice a lot of these in class next time we meet. So try the problem. This completes for us Unit 9, Lesson 3.